This video is just a quick introduction to Newton's third law. It's different than the other two laws in that it describes, rather than just talking about the force acting on a particular object like we've been doing, it talks about, Newton's third law talks about how objects interact with each other. So the two objects are really important. There's always an agent of the force, which is like the thing that's doing the force, and then there's the object that the force is acting on. So before we only really cared about what object am I talking about, what are the forces acting on that object. Now we're going to ask the question, what's causing that force? So I mean, we all know Newton's third law. It's something you hear a lot. My kids who are 8 have been able to recite it since they were 4, and that's not necessarily because of me. But this idea of action reaction is a very common in our society. Anytime you turn on a football game, you'll see like a Gatorade commercial where there'll be like, for every action, and some runner running really hard, and then it'll be like, there exists a reaction, and then you see someone drinking a Gatorade, and it's supposed to represent somehow this law, which it totally doesn't, and drives me crazy. But I digress. So the one thing I will say is we know the law says for every action there exists an equal and opposite reaction. Some parts of it that get left out sometimes are the fact that the force has to be equal in magnitude but opposite in direction. And there's one more thing here that I didn't write in this little square, but I should have probably, and it's that the forces occur simultaneously. The forces occur simultaneously. And that's important. And the reason it's important is because when two things happen at exactly the same time, there is not really the same, like when you say action, you kind of imagine that happens first. And when you say reactions, you imagine that happened because of the action. That is not the case. There is nothing causal about these forces. Action reaction pairs are simultaneously, so one doesn't cause the other. So I mean, that's kind of I mean, you can say, okay, let's say I hit my brother in the face. You could say the fact that you hit him caused his face to hurt. But from the perspective of physics, it's just as correct to say, well, his face hit my hand, because they happen simultaneously. So when I say one doesn't cause the other, I don't mean like intentions and all that. I just mean purely the act of creating a force. We'll do some examples that illustrate this. But the last thing I want to say about this law, you can read this part here in the notes, but so basically this is the key thing here. No force in nature exists without its equal and opposite reaction. So action reaction pairs always exist. It's important to note that they do not, this is a really key thing here, they do not act on the same object. Action reaction pairs do not act on the same object ever. So this is the part that's going to trip you up more than anything else. Don't ever draw objects on forces on one object and say that they're action reaction, because they have to act on separate objects. And then here is where we talk about simultaneously. Okay, so let's do some examples. The first one said, so we're going to draw a free body diagram showing the action reaction pair. So the first one is a bullet being fired from a hunting rifle. So now we've got two objects. I mean, why does a bullet go flying? It's because, you pull the trigger, there's a spark and some combustion, there's compressed air that it pushes the bullet out. So the reason the bullet goes flying is because, and I'm going to write it intentionally like this, there's a force from the gun on the bullet. So the way we're going to do this is that this is the agent of the force and this is the object, right? And all we do to find the Newton's third law force, the reaction force, is we just swap these words. So if you think of, and then you'll notice that I drew this arrow on the bullet because it's on the bullet. So I've got it on the bullet, right? So now if we swap those words, bullet on gun, that means I have to draw a force over here that's equal in magnitude. So equal in magnitude. You can see it's opposite in direction. And I can label it here the force of the bullet on gun. So now the agent and the object have switched. The bullet is exerting a force on the gun. So these two forces are equal and opposite reaction. Anyone who's, I don't know if anyone out there has actually fired a gun, but there's this concept of recoil. And that's like you can sort of feel the recoil or kickback. The other word is kickback. Something's going on with my pen. Kickback. Is it dying? No. Okay, kick back. So the idea of kickback is if you fire a gun, you have to sort of brace it on your shoulder. And anyone who's fired a gun will feel that pushing back on them. If you Google kickback accidents with guns, you'll just, there's quite a field of people who don't know how to fire a gun holding it wrong and like breaking noses and all kinds of things. The next one question is, a football is kicked during the homecoming game. So if the football is kicked, then it's going to experience a force sort of like this. And this is the force, oh my goodness, the force of the foot on the ball. Okay, and again, we have an agent and we have a object. We're going to swap those two words and we're going to place the reaction force on the opposite object. So I've got my here equal in magnitude, opposite in direction. This is the force of the ball on the foot. Okay, action, reaction. The next one, an apple falls from a desk. We're going to ignore air resistance in this question. So the idea here is that what's the force that the apple experiences as it falls from this desk? Well, the way I've drawn it here, it's already fallen, so it's just a little bit ways, and the only force acting on it at this point is the force of gravity, Fg, right? And so Fg is acting on this apple, so that kind of doesn't put us in the same like agent object. So let's expand this force of gravity and call it, like, describe it. What is the force of gravity? Well, it's the force of the earth on the apple. Okay, and again, when we switch those words, we get the force of the apple. So we're going to take that word, we're going to swap that object and the agent. And so what we find is we get a force of the apple on earth. So what that means is, and it's kind of bizarre, but you have to draw the force on the earth. I don't know, maybe this is the earth, which is just like under the table. You have to draw that force there. So here's that force, and this force here, let's see, this force is here. Okay, so yes, it's an interesting idea that the apple is actually exerting that force back up on the earth. The last one I'll do here is a fly collides with the windscreen of a car. You would imagine that, the fly definitely has the worst end of this situation. But when you look at the actual forces involved, what you'll find is that so the fly definitely experiences a force of the fly from the car, force of the car on fly. And the reaction force, we swap those words, is the force of the fly on the car, and that is an equal in magnitude and opposite in direction. And so the car actually experiences the exact same force that the fly does. This is the force of the fly on car. And the idea here is that the forces are equal. We'll talk about more about its implications in a later video or in a later class.